Hi everyone, in this video we're going to have a quick chat about velocity and displacement graphs. Now everything in this we already know how to do. Similar to the last unit, we're just bringing some of those skills together and adding in a few more words essentially. So what I have here is the formula for velocity and the formula for speed, and if you've done any kind of sciences, these both should look very, very familiar to you. We've been looking at speed over the course of this unit, so distance over time, and we sometimes call it as well rate of change. So when you see rate of change or speed, we're talking about the derivative. Okay, we're talking about how much x and y are changing. Another one that we need to look at is velocity. So velocity is displacement over time, and if you can't remember that from science, displacement is, so say you ran the 400 meters, you do that big loop at the athletics carnival, you come back to where you started, your displacement is 0. You haven't moved from where you've started, so your velocity is 0. Okay, whereas speed, you run 400 meters, so it would be 400 divided by your time, and you'd have a speed for that. So velocity is just displacement, but apart from that, it's treated very similar. And in this course, you can almost use them interchangeably, velocity and speed. So what I've done here is my first little graph down here shows the velocity, so the displacement over time. And my second one here shows the speed, so distance over time. What I'm going to get you to do as practice for this, there's only probably 1 or 2 questions on your assignment and your test, is actually go to the Cambridge textbook and work through 16E. So there's 2 different velocities that we're looking at, same as when we initially did rates of change, there was 2 different ones. So we have average velocity and we have instantaneous velocity. So if we've got average velocity, they might ask for the velocity from 2 seconds to 5 seconds. Whoop. And what you're going to do, you're going to find the point at 2 and at 5, and you're going to find the linear function that gives that velocity over that time. Okay, exactly the same as when we did it with rates of change. So that is an average velocity. If they ask you for an instantaneous, that's the derivative. Okay, so if they ask you for the velocity when the time is, say, 15 seconds, this graph is not helping me out here. Okay, we're looking at that rate of change at that exact point. Okay, so very, 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 very similar to when we did rates of change, except you will see the word velocity. Okay, and I'll give you an example of that. There was a question here, question 4. Okay, so the graph here is position time, so velocity. And question A, what time is the instantaneous velocity 0? So if you're getting confused with the word velocity, swap it out for rate of change. At what time is the instantaneous rate of change 0? When's the gradient 0? Okay, so we're talking about turning points. Okay. So very, very similar, but takes a bit of practice. And the best practice for that is 16E, question 1, 2, and 4, and then you should be ready to go with your assignment and with your test.